You know when someone says, "Don't play God," it's best to listen. Scientists have created an artificial intelligence that was designed to identify dangerous volcanic eruptions in real time by examining all the available data. The AI worked great at first, but then something strange happened. It started predicting a huge eruption at Mount Vesuvius that threatened the lives of 3 million people. But there was one small problem. There wasn't going to be any eruption because Vesuvius hadn't rumbled in 1,000 years. This fake prediction revealed some serious issues with AI and made us wonder if we should just leave the volcano monitoring up to humans. Now, this isn't the first time artificial intelligence has gone wrong. A self-driving car that couldn't tell the difference between a pedestrian and a dog ended up crashing into a wall in 2018. And in 2019, an AI designed to detect skin cancer missed spots that were clearly cancerous. And while these mistakes are annoying and potentially very painful, they're nowhere near as catastrophic as what would have happened if that AI had predicted an eruption at Vesuvius. So, how did this AI make such a big mistake? Well, let's take a look at what it actually does. Volcanoes are scary, which is why scientists want to monitor them closely so they can warn people when an eruption is imminent. But monitoring a volcano is a full-time job. You need experts who watch for gas emissions, ground deformation, and seismic activity around the clock. So, in 2021, scientists in Italy decided to develop an AI that could help with the monitoring. They trained their AI using data from previous eruptions at Mount Vesuvius, including the one that buried the Roman city of Pompeii in 79 AD. It learned to look for the same kinds of signals that volcanologists do, and at first it was really good at its job. It correctly identified smaller eruptions at Vesuvius, as well as other volcanoes in Italy and Iceland. But then, in 2022, things got weird. The AI started giving false positives, claiming that Vesuvius was about to blow its top, even though there was no sign of any activity. And not only that, the AI predicted that the eruption would be huge, causing 3 million people to evacuate the surrounding area. That's roughly the population of the entire metro area of Los Angeles. So scientists took another look at the data they fed the AI. They double-checked everything, making sure there weren't any errors or signs of an impending eruption that they had missed. But everything checked out. So what went wrong? Well, it comes down to one of the biggest problems with artificial intelligence, and that's the fact that AI doesn't really understand the world. It can only mimic understanding. Let's go back to the self-driving car that couldn't tell the difference between a dog and a person. That's not because the car lacked processing power or sophisticated cameras. It just didn't have the ability to understand the world in the way that humans do. To a computer, a dog is just a fuzzy yellow thing running across the road. And unfortunately, AI's understanding of the world is limited in a similar way. In this case, the AI had learned to associate certain data with volcanic eruptions. For example, an increase in gas emissions and ground deformation usually means that magma is rising under the volcano, and rising magma often leads to an eruption. So the AI was looking for those two things specifically, but it didn't understand why they were happening or what those changes meant for the volcano overall. It just knew that those things happened before an eruption, so it assumed that they must cause the eruption. So when the AI saw a rise in gas emissions and ground deformation, it jumped to the conclusion that there must be magma moving under the volcano, even though there wasn't. And here's where things get complicated. In reality, there are a lot of things that can increase gas emissions and change the shape of the land around a volcano without magma being involved. Water that seeps into the cracks of a volcano can cause steam to escape, for example. Or water can also dissolve in magma deep underground and cause the ground to bulge. The AI wasn't able to account for these more complex interactions. It could only spot the patterns in the data it had been trained on. And this isn't unique to this particular AI. Most artificial intelligence works the same way. Take that AI that was supposed to detect skin cancer. When it looked at a picture of someone's skin, it was only scanning for the features it had seen in the pictures it was trained on. If it came across a mole that wasn't exactly round, it didn't consider the possibility that it could be a benign beauty mark. It just flagged it as a potential problem. Now, in some situations, this kind of overzealousness can be useful. If you're training an AI to detect fraud, you want it to flag as many suspicious transactions as possible so that humans can investigate further. But in other situations, like detecting skin cancer or predicting volcanic eruptions, you don't want false positives because they waste time and resources, and they can even be dangerous. So, what can we do about it? Well, one solution is to simply train the AI on more data. In the case of the volcano monitoring AI, that means feeding it data about non-eruptive events that still cause changes in gas emissions and ground deformation. That way, it won't jump to the conclusion that every time these things happen, there's going to be an eruption. The problem is that collecting this kind of data is difficult and time-consuming. And that's not the only problem. Even if you train an AI on tons of data, it still won't understand the world the way humans do. It'll always just be looking for patterns. So some researchers are taking a different approach. They're building AIs that are based on the way the human brain works, which means they're able to simulate things like common sense and experience. But this approach is still in the early stages, and it's unclear whether these AI systems will ever be as accurate as the ones we already have. So for the time being, we're still a long way from handing over the controls to robots. In the meantime, it might be wise to leave the heavy lifting to humans. After all, we're the ones who came up with the idea of don't play God in the first place. At Minute Earth, we love exploring the unexpected ways that the world around us works, and one of the best ways we've found to do that is through games. This is a game that puts you in control of a planet. Your goal is to keep your planet's core from getting too hot and blowing up, which turns out to be trickier than we thought it would be. You can add land, oceans, and even continents to your planet, and then watch as water flows and wind blows across its surface. It's a fun way to learn about the physics of our own planet. Thanks for watching this video.